Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the like check. Anyways, the agenda behind today's video, I was planning to take the probability, but still when I was looking back, the different kinds of the problem has been picked up from the concept of the integration. The spatial kind of the integration has been a very important topic for the electrical, electronics as well as the instrumentation. And three of the students who have been concurrently watching my videos, they have been from electrical, electronics as well as instrumentation. So it is responsibility of mine to take care about the important topic for the student who have been following me. Yes, agreed what I am saying? So just wanted to know from each one of you regarding the quality of video as well as audio, is it perfectly transmitted from this side or not? Tell me, and then we are going to go ahead. So anyways, I have already consolidated the important problems based on those concepts. Anyways, before going it to the or straight away jumping it to the problem, let me build a little bit amount of basis behind this spatial integration. Tell me the quality of video and audio, is it perfect or not? I want the comment at least from one people. So at least I'll have the fair idea that the video as well as audio is properly transmitted from my side. Perfect, no? Okay, then it's fine. That's fine. See what I am saying, the spatial kind of integration which I am going to deal today now, it's gonna be Laplace integration. Many of the students may not have heard about this, but the question do come from this segment repeatedly. So we have been dealing with the Laplace integration. First try to learn the basic behind the Laplace integration, and we will also try to understand which kind of the problem would come under the preview of Laplace integration. My dear friends, once you'll go into the basics behind the Laplace transformation which we perform over the engineering mathematics, over the signal system, over the communication. So for the time being, keep aside the signal system as well as communication, just focus over the different kinds of the time domain function as well as its Laplace transformation. My dear friends, just try to understand in this way. The first important point I am going to write within the Laplace integration. You had a function in time domain. Let's take it has been written as x of t, where the x has been a function and now the t has been a variable, so I can say x has been a function of t. Once we take its Laplace, how it's been written? Obviously, we get a new function and now the variable would be s. Anyways, this was just a mathematical representation that the x of t has been a function which has been a function of time, and similarly x of s is nothing but the Laplace transformation of x of t, which is a Laplace transformation of x of t. Agreed, sir? Till this point, no issue, sir? We know till this point. Yes? We know till this point. Yes. In the same sequence, what I am saying, how mathematical is being calculated? What I am saying, as far as capital X of s is being concerned, it's been written as Laplace of the time domain function x of t, but mathematically how it's been calculated? It's been calculated by a improper definite integral, where the integration of xt takes place along e to the power of minus st, which starts from 0, goes till infinity. Agreed, my dear friends, what I am saying? So end of the day, what's going to be the result over here? As the integration has been taken place in terms of t, so obviously t would not be present once its complete definite integral is performed. So obviously the result is going to be the function of s alone, and that is nothing but the Laplace transformation of x of t, or I can say the Laplace transformation of small x of t. Agreed? Could you understand what I am saying? Should I be repeating once again? Let's take, you had a time domain function x of t, and as far as the Laplace of this time domain function is being defined mathematically, it is being written as capital X of s. Why the small of x has been changed to the capital of X? Because once we take the Laplace of any time domain signal, its function changes. Like for 1, the Laplace transformation used to be 1 upon s. Like for t, the Laplace transformation used to be 1 upon s square. So what is happening? The function itself is going to get changed. That is fine, sir. And as far as mathematical calculation of Laplace of x of t is being concerned, it has just been dealing with the form of definite integral. So what I am saying, being a student from engineering background, you already know few of the important Laplace transformations. What does it mean of it? Like, you know the Laplace transformation of 1 is going to be 1 upon s. You know the Laplace transformation of t would be 1 upon s square. You know the Laplace of t square would be of 2 divided by s to the power of 3. What does it mean of it? If you know the Laplace transformation of few of the critical as well as important function, basically you know this integral value when the value of xt was 1, when the value of xt was 2, when the value of xt was t square. Not only that, even many of these students may be able to remember the Laplace of sine of at used to be a divided by of s square plus of a square. Virtually you are saying, sir, I know integration from 0 to infinity of sine of at e to the power of minus st dt is equals to of a divided by of s square plus of a square. Now the people would say, sir, we also know about cos of at. How the cos of at Laplace is being written? Is being written as s divided by of s square plus of a square. So logically speaking, you know the integration from 0 to infinity of cos of at e to the power of minus st dt. That means, being a student from the electrical, electronics, instrumentation, mechanical, civil, production, any of the branch, you know many of the important Laplace transformations. That means you know many of the integral values, Nishan Sharma, my basic agenda behind this formulation is not to discuss about the Laplace transformation. Otherwise, as the question you have raised over here, no, it is a very genuine question, and just to explain those problems into the great detail, it may take 1 hour. So I am not going to discuss about the convergency and all, because the S would have its real part as well as imaginary part. I am not going to go into the detailed part of it. So probably till this point, I don't find any of the students would have any sort of doubt. In the same sequence, let me move forward. In the same sequence, let me move forward. Let me recall few of the important time domain signal and its equivalent Laplace. Let's take the time domain signal is being referred as x of t, and this equivalent Laplace is being referred as capital X of s. Capital X of s. May I know, if I take a time domain signal whose had the worth of 1, keep in mind, whenever I say time domain signal, the worth comes into the picture. The worth starts coming in the picture from t is equals to 0 onwards, and you can see, at least in mathematics, I start my integration from 0 to infinity. In control system, in signal system, in communication, we used to write this as u of t. U of t has the worth is equals to 1 from 0 onwards, and towards the negative value of t, the value used to be 0. Anyways, forget about each and everything, just focus over the calculation which we have been doing over here. One would have the Laplace is equals to of 1 upon s square. Yes, sir, we know about it, nothing great in it. T has the Laplace is equals to, just a minute, T has the Laplace is equals to of 1 upon s square. Yes, sir, that is also known to us. In general, if t has been raised to a certain natural power, what used to be the result of it? N factorial divided by of s to the power of n plus 1. That is also known to us, sir. That is also known to us. Yes. In the same sequence, if we move forward, let me take an important trigonometric ratio, and that has been sine of 80. May I know what used to be the Laplace of it? The Laplace used to be a divided by of s square plus of a square. Yes, sir. Very well. We know about it. In the same sequence, let me do one thing. Let me bifurcate this complete digital board into the 2 segments, such that I would be able to list down few more important Laplace equivalent. Again, we have been taking an important time domain function, and near to that, we would be writing its equivalent Laplace. In the same segment, if I take sine of 80, instead the sine of 80, now cosine function is being taken. May I know what used to be the Laplace of it? It used to be s divided by of s square plus of a square. There are several important time domain functions for which definitely I presume that you guys knows about its Laplace equivalent. That's fine. No issue, sir. No issue. See, just try to understand. What does it mean of it? If you know the Laplace of x of t as 1 upon s, basically you know integration from 0 to infinity, xt is being fed as 1, e to the power of minus st dt is equals to of 1 upon s, sir. Yes, sir. That's fine. Nothing wrong in it. In the same sense, if I say, if you know the Laplace transformation of x of t as t as 1 upon s square, x of t would be fed as t. So basically, you have already concluded the integration from 0 to infinity, t times of e to the power of minus t dt is equals to of 1 upon s square. 1 upon s square, that is also fine, sir. Not only that, if you know the Laplace equivalent or the Laplace transformation of sine of at, obviously which had been a time domain signal, is being integration from 0 to infinity of x of t. What had been the x of t over here? It has been sine of at, which is getting multiplied with e to the power of minus st dt. E to the power of minus st dt. What had been the worth over here? The worth had been a divided by of s square plus of 1. S square plus of 1. Okay, sir, it looks okay. Whatever you trying to communicate, no, it looks okay for me. So in future, what I am saying, the few of the datas which you know already, can't it be framed in a form of integral? So in future, this sort of problem are going to get asked specifically for the electrical, electronics and instrumentation. What they are going to do? They are just going to give this part. And they are going to ask this part. Now what the student would do, if they have the integration of t into e to the power of minus st dt, they would start scratching their head. Sir, how will I solve this problem? Probably they would be able to smash this problem using the gamma integration. Till this it's okay, but once they go over here, or if they go over the more complex time domain function, definitely they would get trapped. And already you know its integral values. So what exactly I wanted to communicate over this? Taking the important outcome of Laplace transformation, we are going to deal with a few of the definite integral. Definitely form of the definite integral would be from 0 to infinity. 0 to infinity, you would be dealing with certain x of t, you would be dealing with certain e to the power of st dt. Till this point, each and everything is clear or not? If it is clear, just write clear over the live chat, so at least I'll have the fair idea that you guys are clearly following what exactly I wanted to intend till this moment of point. Tell me. Then we would move ahead. I would like to have the concurrence input from each one of you. Till this point, everything is perfect or not? Sir, gamma will be a special case with s is equal to, no, everything is fine. I wanted to ask only one thing. Till this point, is everything is clear or not? If it is clear, just write clear. That's it I want. Clear, no? Whoever says, sir, this part is not there in their syllabus, I can prove them wrong. This sort of problem have come in production engineering, have come in mechanical, civil, and yes, categorically in electrical, electronics and instrumentation, this questions been more repetitive. Yes. So probably till this point, each and everything is more than perfect. So let me start with the first question. I am going to design the different kinds of the problem, and the difficulty level of the questions would be increased as we go downside. So let me take, how many number of problems we are going to take? The 5 number of problems over here itself. If I need to find the integration from 0 to infinity e to the power of minus t dt. Anyways, without using the concept of the Laplace integration and all, tell me how much worth we get it. I would like to have the input from each one of you. This would be my first question of the day. Obviously, first practice question of the day. It's gonna be the second practice question of the day, third practice question of the day, fourth practice question of the day, and here goes the fifth question, practice question of the day. So the student who have been following me, the student who have been have a bit idea about the integration and all, definitely they would be able to say what would be the best most answer for this given problem. Tell me my dear students, what would be the best most answer? Keep aside Laplace and all. Just focus over the integration. It has been a type of improper definite integral. You will take the integration of e to the power of minus t, minus would be jumped out, it would be remained as a e to the power of minus t. You will take its limit, upper limit as infinity, lower limit as 0. So it is, minus is already outside, e to the power of minus infinity, that's 0, minus of 1, put together the result would be plus 1. Yes. So the two answers have been achieved by the Nishant, Manju as well as Pranali. Now let me use the special case of the integration, special format of the integration, special segment of the integration, and that has been the Laplace integration. Laplace integration. My dear friend, if you will try to correlate this form of the integral into the standard form of the Laplace for the given x of t, there must have been the x of t over here, but as the x of t has not been presented, that means the worth of x of t has been taken as 1. Yes. Here I must have e to the power of minus st, but instead the e to the power of minus st, if we have e to the power of minus t, that means once the Laplace of x of t is equals to 1 has been performed, we had to feed s is equals to 1. Can I write like this? Can I write like this? Laplace of x of t, which is nothing but Laplace of 1. Once we take the Laplace of this time domain signal, obviously you would be converting this time domain signal into the Laplace format. We had to feed s is equals to 1. How did we know about it? Now many of the questions would be raised in your brain. Obviously this has been the place of x of t. If this place was empty, obviously x of t was equals to of 1. X of t was equals to of 1. Similarly in standard format, here I used to have e to the power of minus st. The s place was empty, that means the t was simply getting multiplied with 1. Simply getting multiplied with 1. Agreed? So what is happening over here? The Laplace of 1, which is already being seen, it's simply equals to of 1 upon s, sir. Agreed, sir? No issue at all, sir. 1 upon s, but end of the day, the s has to be fed as 1. 1 divided by f 1 is simply equals to 1. How much time we have taken? I would say maximum to maximum 30 seconds. The student who are more acquainted with the calculation and all, probably within 15 to 20 seconds, they would have the result in them. Yes. Agreed? So probably till this point, I don't find any of the student would have any kind of doubt over here. In the same sequence, let me move forward. Let me change the problem a bit. Let's take, it has been e to the power of minus t. Instead the e to the power of minus t, let me have a bit different variety. It has become e to the power of minus 2t. Let's take t over here, and still the integration has been taken place from 0 to infinity. Still the integration has been taken place from 0 to infinity. 0 to infinity. Now if I would say with the help of analytic method, you should be getting its answer, it becomes a disastrous process. It would be a so much mammoth, tremendous process. No, you won't be able to get the answer that easily. That's a different story. Together, the student who have a little bit idea about the gamma integration, definitely with the help of what? Substitution, they can keep 2t is equals to of x, and they may solve this problem using the gamma integration. But still I would say the Laplace integration, which is a special kind of the integration, would be the best way to smash this problem out. Again, focus the standard places. The t has been in the place of x of t. 2 has been in the place of s. So what we are going to do at last? We are going to perform the Laplace. Laplace is nothing but the integration only. Many of the times the student thinks are how you are doing so. My dear friends, the Laplace has been a process of definite integral only, where the integration of x of t has been taken place along with the e to the power of minus st from 0 to infinity. Could you understand what I am saying? So here it becomes Laplace of t, and once you take the Laplace of any time domain signal, result would be the function of s, and end of the day s has to be fed as 2. Yes sir, that is also quite okay sir. May know what's the worth of Laplace of t we have calculated. It's going to be 1 factorial because the power of t has been n is equals to 1. So it's going to be 1 factorial, and towards denominator side it would become s2 power n plus 1. That would be, here becomes s is equals to 2, 1 upon s square. Well and fine, sir. Well and fine. Agreed? No? Agreed? In the same sequence, let me move forward. Let me change this problem drastically different. Let me the problem had been this. Which kind of the problem can be framed? Yes, you can do like this. T has been raised to the power of 4, e has been raised to the power of minus of 4t dt, 4t dt, 4t dt. One question were raised from Nissan's side. Definitely I am going to address that problem in the next case, and definitely you guys are going to trap over there. Sir, can we take Laplace from minus? That's what I am saying. Manju need not to have any thought process at all. Whatever I am saying, just follow it. I know the student who are from electrical, electronics, instrumentation, they would think in the various dimensions. They would say, sir, my signal can be dual banded signal that could be the present towards left hand side as well as right hand side. As far as the mathematics is concerned, no. Assume your function starts from t is equals to 0 onwards. Tell me what would be the worth of it. And then I am coming with a next kind of the question where the most of the students are going to do the mistake. First, forget about each and everything, focus over this problem, try to get its bestmost answer. Tell me, what would be its answer? Students, tell me what would be its bestmost answer. Now you need not to think much. You need not to follow the complete process. Just focus over x of t. Once you put your eyes towards x of t, it is clearly known it has been in a form of t to the power of n. And once we take the Laplace of t to the power of n, the result used to be in a form of n factorial. Here the n had been 4 divided by of s has been raised to the power of n plus of 1, which has been 5. Yes, sir, what happened to EMFT class today? It would be, my dear friends. Obviously, it would be. So, see what is happening over here. End of the day, it has become a function of s, whereas the s has been 4 over here. So, here goes the 4 factorial, and here goes 4 which has been raised to the power of 5. Now, it is your turn to get the answer. The calculator is there in front of me, so obviously I can use the calculator and at least I can get the answer in a form of decimal values. Tell me how much we are getting. So I would like to have the input from each one of you, how much we are getting. So here is gonna be 4 factorial divided by of 4 has been raised to the power of 5. So it is going to be 3 divided by 128. 3 divided by of 128. That is for sure. So the student who have got the answer is 3 divided by of 128, and in decimal this has been belonging somewhere 0.0234. They have been getting the perfectly correct answer. Yes, sir. Himanshu Bharti, sir, what happened to EMFT class today? Himanshu, the class which we used to have on our Gate Academy 2.0, that has been held at the very same time, and even the class which is going to get held over the application, that would also be held precisely at 10:30. The class is not going to change until and unless we do not inform priorly. Yes. Agreed, no? Now almost all of us are going to get trapped over here. Let's take the problem had been t e to the power of t dt. Tell me what would be the worth of this problem. And as I have already communicated, most of the students are going to get trapped over this problem. Many of these students might think a lot and come up with the right answer. But still I am saying what would be its best most answer. At least two best answer I want for this problem. At least two best answer I want for this problem. Tell me what would be the best most answer for this given problem. This given problem. Tell me. What would be the best most answer for this given problem? Many of these students are going to do the mistake over this specific problem because this problem has been designed in such that you guys are putting yourself in big trouble. Big trouble. Yes, Nissan says infinity. Infinity. Anyone else? Anyone else apart from Nishant? See what the people would do, they would just again focus over the x of t. They would say, sir, the x of t is known to me t. The Laplace transformation of t is clearly known to me. What used to be the worth of it? It used to be n factorial, which has been 1 factorial, sir, which stands for 1 itself. And towards the denominator side, the s has been raised to the power of n plus 1, where the n has 1, so obviously it would be raised to 2. And as far as the substitution is concerned, e to the power of minus s to st has to get compared with the e to the power of plus t. So the worth of s is gonna be minus 1. So many of these students would come up with the answer as 1. Yes, Savan Kumar says the answer is 1. No, it's not the case, my dear friends. As far as the starting 3 problems which we have taken now, they were perfectly bounded signal. If you want, I can show there. If you want, I can show over the graph itself. Let me write somewhere and then I would try to show over the graph. See, e to the power of minus t, it's a perfectly bounded signal. So as far as definite integral is being concerned, no, definitely it would be a finite value which has been 1. T, e to the power of minus 2t, it has been a definite function. It has been a bounded function. So in between 0 to infinity, it is going to concern, or it is going to concede a constant value. It is going to concede a constant value. So as far as this problem is concerned, keep in mind, the answer would be divergent, my dear friends. Nobody should write even infinity, because you have been dealing with the definite improper form of the integration, and at any moment of time when the output answer result goes towards plus infinity minus infinity, that's done. The answer is simply equals to of what? Divergent in nature. Divergent in nature. So Savan Kumar, the answer which you have put in over the live chat, that has been a trap, and probably you got trapped over there. You got trapped over there. Whether you want me to show this all function, over the graph, just to know whether they have been the bounded function or not. If you want, I can show it there. I can show over there. So let me write all of the functions. The first function was e to the power of minus t. What was the second function? The second function was t e to the power of minus 2t. What was the third function? It was t to the power of 4 e to the power of minus 4t. And what was the last function? It was t e to the power of plus t. Anyways, I can show this thing over the graph, and even you yourself would be able to understand. See, at t is equals to 0, the worth would be 1. At t is equals to infinity, e to the power of minus infinity value would be 0. At t is equals to 0, this becomes 0, the function would be 0. And at t tends to infinity, e to the power of minus infinity becomes 0. Again, the worth of the function is 0. That means it's a perfectly bounded signal. Not only that, here also the same thing. Now, at t is equals to 0, this becomes 0, function is 0. At t is equals to infinity, this becomes 0, function is again 0. It is a bounded function. But here this is not the case. But here it is not the case. Once you will feed t is equals to 0, this becomes 0. But at t tends to infinity, this becomes infinity, and e to the power of infinity would also be infinity. And hence it is gonna be a unbounded signal. And that is why the student who have been the part of electrical electronics instrumentation, they cover region of convergence. What does that mean by the region of convergence? Just wanted to ask from each one of you, do you exactly feel the concept of region of convergence? Region of convergence is the same fundamental which we use in case of improper definite integral. If the result is being found finite, keep in mind that form of improper integral is said to be finite or convergent. or if the result goes towards plus infinity or minus infinity, it's called divergent. And for that only, we try to get the reason of S, the reason of S. Could you understand what I am saying? Could you understand what exactly I wanted to say over here? So obviously, sir, we would be able to agree on it. We would be able to agree on it. Yes, sir. We are agreeing on it. चलो एक चीज और भी देख लो. Yes, एक चीज और भी देख लो. Just focus over one more important thing. See, we call the reason of convergence. My dear friends, just try to understand in this way. If you are interested finding the Laplace of t, how it would be calculated mathematically, it would be calculated t into e to the power of minus st dt, where t would start from 0 and would go indefinitely high towards infinity. May I know, I would like to ask from each one of you, just focus over this problem. I know this problem is going to cover almost all of the gray areas which you have for the Laplace integration, for the Laplace integration. May I know, this answer would be finite, that means convergent, or would be infinite, that is divergent? Would it be convergent or would it be divergent? That solely depends on the value of S. If the real value of S, what I am saying, real value of S, because the S would have the imaginary part as well as real part. Imaginary part would be keep oscillating, but the real part is the part which is going to decide whether this complete function is going to decay or whether it's completely increasing in nature. So what I am saying, the result used to be 1 divided by of S square, but along with this we also write the real part of S has to be greater than 0. If the real part of the S has not been greater than 0, or if it has been lesser than 0, so you can feed real S is lesser than 0. Let's take the worth has been taken as -1. So once you will feed e to the power of -1, it would become e to the power of plus t. In that case, this integration would not be convergent, it would become divergent. So Manju, probably after taking this example, not exactly all of the doubts, but most of the doubts would have been smashed. Would like to ask from each one of you, the student who wanted to know a bit about the reason of convergency could really understood this concept or not. And anyways, this all concepts are being connected with my special kind of the improper definite integral, and that has been Laplace integration. It's not s greater than 0. I repeat, it's not s greater than 0. It's a real of s greater than 0. I repeat, it is a real of s greater than 0. Because just try to understand what has been discussed over here. It used to be having the two part. This has been the oscillating part. It's not going to make any sense over here. It's not going to make any sense over here. Sorry, t would come over here. So just focus over this term. Yes, this term. If the power has been negative, definitely this complete function would be a strictly bounded function, and if its power has been positive, this function would not be a strict bounded function, and that's done. That's done. Anyways, before going into the detailed analysis of the topic which we have been covering so far, if the concept of the reason of convergence has been clear a bit, you can just put it yes over the live chat. Otherwise, if you have any specific kind of doubt, you can put it over the live chat. You can put it over the live chat. Sometime mod of S is why, no, who said? No, nobody has taken it. If you want, just show me. The mod is being taken for jet transform, my dear. It's not been taken in case of Laplace transformation. If you have that, you can show me over the Telegram group. Definitely, I would try to cover that part also. The mod is being taken in case of jet transformation, and the real part of S is being taken in case of Laplace transformation. and I can say we would be spending around 45 minutes or 50 minutes in daily basis, because back to back I am having the 3 number of classes, so I don't want to deteriorate my quality at any sense. Either it is a live class over the Gate Academy Global, either it is a live class over the Gate Academy 2.0, either it is a live class over our live app, and even my parallel recording for the analog is also going on. So I don't want to deteriorate my quality. So what we are going to do, we are going to just shrink the span of time which we spend together in daily basis. In each of the lecture, I would be cutting around 10 minutes. I would be cutting around 10 minutes. Clear now? Pranali says clear, Manju says clear. That's more than fine. That's more than fine. In the same sequence, let me move forward. Let me move forward and let me design another problem and try to get its best most answer. Try to get its best most answer. Let's take the integration, which is a type of improper indefinite integral, e to the power of minus 2t sine t dt has to be performed. Tell me what would be the worth of this problem. Sir, parallel comparison when it will be R. No. If R reason a real part of S is lesser than 0, in that case the area under the curve would become infinite, and that time it is being said the Laplace transformation for that reason is not been defined. It's also called non-convergent. It's not been defined. It's also called non-convergent. Anyways, focus over the next problem. Tell me what would be the worth of this problem. Just focus over the Laplace of sine of t, and instead the S, the 2 has to be fed in. Laplace of sine of t, how it's been defined? It's been defined as a, the worth of a had been 1, obviously sir, we agree on it, divided by of s square plus of a square, where the square has to be raised for 1. Till this everything is fine, sir, and here s has to be fed as 2. End of the day, such a beautiful answer we get with such a minimalistic number of steps, and that had been 1 upon 5. That had been 1 upon 5. That had been 1 upon 5. So I think this concept must be clear to all of us till this moment of point. Till this moment of point. Yes. But make sure whenever the integration is being performed using the concept of Laplace integration, the given function must be a bounded function and must be enriching the finite area. And as far as e to the power of minus 2t sine t is being concerned, if you want, I can show I have written all of them now. So end of the day, I would be showing those graphs over the 2D graphic. Yes. How the e to the power of minus 2t sine t would look like? E to the power of minus 2t would become the envelope, and sine of t would be oscillatory signal. So here the outcome would be sort of this, or the curve would be sort of this. It would start from 1 and minus 1, and it would be keep decaying. Why I have taken envelope towards upside as well as downside? As far as e to the power of minus 2 is being concerned, its worth for positive, or all possible values of t would always be positive, but once it gets multiplied with the sine of t has been oscillating signal which can have the values as plus and minus both. So once their multiplication takes place, sometime it goes upside and sometime it goes downside. May I know when it would be upside? It would be upside when the worth of sine of t would be positive. When the worth of sine of t used to be positive, you can take from 0 to pi, then you can take from 2 pi to 3 pi, then you can take from 4 pi to 5 pi. So here the curve would be sort of this. Agreed, no? And as it has been exponentially decaying, end of the day, once you would start adding their areas, you would be getting a finite area, because anyhow at the end they are going to dull down. So the worth had been 1 upon 5. So possibly till this point, I don't find any of these students would have any sort of doubt. All of these students would be clear till this moment of point. Agreed? Let me take the next question. and I would say it is a better design problem. It is a better design problem. We have taken the integration, just a minute. We have taken the integration of sine of t which has been divided with t dt, where the t goes from again 0 to infinity, 0 to infinity. Tell me what would be the best most worth for this given problem. What would be the best most worth for this given problem? So this much thing we have studied in today's lecture. At very beginning we were having a little bit basics behind the Laplace transformation, and once we were done with that, we have taken few number of practical problems which can be mounted, which can be derived from the spatial kind of the integration, and that has been the Laplace integration. That has been the Laplace integration. Tell me, what would be the best most answer over here? See, e to the power of minus t, yes, answer have started coming. Manju Sudha Khan says pi. Manju, I am sure about it, you have not calculated this. Would like to ask whether you have calculated this or whether you are able to recall what used to be the worth for this given function. Nishant, I would like to ask from you also. No, that's fine, no, it's a single function, that's fine, everything is very fine. But what I want to say, whether you are able to recall this result which you have studied somewhere, or whether you have calculated this integration here itself. First give me the reply and then we will try to smash this problem out. Tell me. See how we can smash this problem out with the not calculated. That's what I am saying. No, Manju, just try to understand how this problem could have been smashed. How this problem could have been smashed. What you can do, just try to understand. In standard, I used to have e to the power of minus st. At least in this problem, it had been e to the power of minus 0t. That means once in future, the Laplace of sine of t would be calculated. No, sine of t would be calculated. The complete function would be the function of s, and there instead the s, the 0 would be fed in. 0 would be fed in. Yes. So here becomes the Laplace of sine of t divided by of t, and obviously the result is gonna be the function of s, and instead the s I would be feeding 0. And now even while calculating the Laplace of sine of t divided by of t, you can use the important property which is nothing but the division in time domain. Division in time domain. Yes. So what is happening over here? So let me recall what used to be that property. It states Laplace transformation of x of t, if it is getting divided with t, is simply equals to of Laplace of x of t, which has been x of s, where the integration goes from s to infinity d of s. D of s. That means what we had to do over here, we had to take the Laplace of sine of t. We had to take the Laplace of sine of t. What would be the worth of it? Its worth would be a had been 1 over here, divided by of s square plus of 1, and now you would take its integration, and that too from starts from s and goes till infinity over ds. Still the result would be in a form of s. Why? Because lower limit itself has been s over here, and end of the day whatever the result do come, I would be feeding s is equals to 0. I would be feeding s is equals to 0. Tell me what used to be 1 upon s square plus of 1, antiderivative. Antiderivative would be tan inverse of s. Tan inverse of s, where its limit has been known to be s and it goes till infinity. Again the result would be in a form of function of s, and once we get the form in a function of x, I need to feed s is equals to 0. I need to feed s is equals to 0. So end of the day, we have got tan inverse of infinity, which worth used to be pi by 2, minus of tan inverse of s, and s has to be fed as 0 while taking its lower limit. While taking its lower limit, tan inverse 0 is 0. End of the day, the result which we are getting in our hand is simply going to be pi by 2. It's simply going to be pi by 2. So I do not understand which particular discussion is going on. Recalled sir, integration property of Laplace. I posted the same question to him yesterday. I don't understand. Nissan, give this problem in Telegram. So wanted to know from each one of you whether you guys were aware that this integration can also be performed with the simplistic form of the Laplace integration or not. Because many of these students just by heart this integration, because this has been an important integration in terms of signal as well as communication, but it has been calculated from here. It has been calculated from here. How many times it has come? In electronics, electrical, instrumentation, probably 7 to 8 number of times this straight problem have come. Just they were focusing over the integration of sin t divided by t, sin t divided by t. Yes. Let me take another problem. Which problem I can take, my dear fans? I can take. Yes. Integration which has been raised to, where I can raise, my dear fans. Okay. Minus infinity to 0 sine of t dt. I would like to have this answer from each one of you. Tell me what would be the worth of it. My dear friends, deliberately I have built this problem just to make you guys in bit trouble. As far as sin t divided by t as a function is being concerned, it has been an even function. What does it mean by the even function? This function, if it folds taking the reference of y-axis, what would happen? The function which was there towards left hand side would get fallen over right hand side function, or the right hand side function would be fallen over the left hand side function. Put together from 0 to infinity, it's going to concede the same area, and similarly from minus infinity to 0, it's going to concede the same area. So whatever the result you would be having for this, it would be very same as the integration from 0 to infinity sin t divided by of dt, which we have already calculated here. Pi by 2, it was earlier, pi by 2 would be right now. Yes, pi by 2. Even the same problem could have been designed in the different format. In future, I would expect this sort of problem may come in your GATE examination. They are rather taking the integration from either minus infinity to 0 or 0 to infinity. They may take the integration from minus infinity to infinity. What would be the worth? From minus infinity to 0, the value is known to be pi by 2, and here also it's pi by 2. This has been the result. This has been the result. So I would say in future a specific problem where the Laplace of that given time domain function is known to me, you would be able to get the answer. Anyways, let me design another problem also. I know many of these students would have a lot of pain while calculating this. Let's take x goes from 0 to infinity. What would be the worth of it? I know many of these students may have a little bit problem while calculating this definite form of the integral, obviously in form of improper. Tell me what would be its bestmost answer. Same, no, that is what I am saying. Many of the students would think, sir, here x is being applied and the Laplace connects the time domain function to the Laplace domain function, then how x and t? My dear friends, it has been a basic property of the definite integral. At any moment of time, if the function as well as its limit is not being changed and only the replacement in variable is being taken place, the result would remain same. the result would remain same. And now as the calculation has been made over the time domain, at any moment of time, you can bring this calculation towards Laplace domain, you can apply the Laplace transformation and you can get the answer. You can get the answer. Could you really feel what exactly I wanted to communicate through this concept? Because this sort of problem would be there. If I would frame the problem, no, definitely I would keep this trap point in my mind while designing the problem. Because whenever the T do come in the picture, no, or T comes along with the problem, so the student who have read the concept of a signal system, have read the concept of Laplace transformation, they would be able to connect the problem easily with the Laplace transformation. But once we have been dealing with the X, probably you may have a little bit doubt. You may have a little bit doubt. Anyways, this is all about the today's lecture. And as I have communicated, probably we are going to spend merely 50 minutes in daily basis on both of the channels, because I am going to have all 3 lectures. This is all about the today's lecture. We would meet precisely at same time at GATE Academy 2.0 as well as GATE Academy Global as well as our application. Bye bye, take care, good night.